Production, GenAI doesn't stay fixed. Data shifts, users change, providers update, and quality can quietly regress. In this topic, we'll look at how to detect drift, diagnose issues, add human review, and turn production signals into continuous improvement. At this point, you've built the foundation: architecture, safe deployment, and quality measurement for GenAI systems. After launch, the challenge changes. Models, data, prompts, and users all keep moving. This section connects observability, evaluation, versioning, and SLOs into one operating loop for catching drift and preventing regressions. A GenAI launch is not a finish line. The system depends on inputs and dependencies that continue to change. Users ask new kinds of questions. Documents are revised, retrieval indexes age, prompts get adjusted. Model providers update behavior, and APIs or policies can shift underneath you. As a result, quality can erode even when your application code has not changed. Sometimes that drift is gradual. Other times, one release creates a sharp regression. The first signal is often business impact. More escalations, fewer resolved tasks, lower trust, or higher cost. That is why monitoring and evaluation must continue after launch. Think of drift as any production change that moves the system away from the assumptions you validated. For LLM applications, that change can happen in more places than the training data. Documents may change. The embedding model, chunking, index, or ranking logic may change what context is retrieved. A prompt edit or a shift in user intent can change interpretation. Tools and providers can also drift through API behavior, latency, pricing, safety filters, or model updates. This taxonomy matters because it tells you where to monitor, where to test, and where failures may be hiding. Data drift happens when the knowledge your application retrieves no longer matches reality. The model may be fine, but the context it receives is stale. An old price, a deprecated API, an outdated policy, or missing new documentation. In RAG systems, this often comes from broken ingestion jobs, bad metadata, or chunks that remain indexed after the source changed. Treat freshness as an operational metric. Track when sources were updated, when they were indexed, whether ingestion jobs succeeded, and whether each source meets its freshness SLA. Retrieval drift means the LLM is answering from a changing evidence base. The prompt and model may be identical, but if embeddings, chunking, filters, or similarity thresholds change, the top results can shift. Good context may become noisy, duplicated, irrelevant, or incomplete. That shows up as weaker grounding, missing citations, and confident answers based on the wrong passages. Treat retrieval like a production dependency. Before rollout, test representative queries and track precision at K. Recall at K, ranking quality, citation correctness, and context relevance. Prompt drift happens when a small prompt change quietly changes the model's behavior. A new example, formatting rule or refusal instruction might improve one case and break another. That is prompt regression. Treat prompts like code. Version them. Record why they changed, test important behaviors, and keep a rollback plan. The goal is simple: improve intentionally without losing what already worked. User intent drift is a reminder that your users are not static. A system can keep the same model, retriever, and infrastructure, yet still feel worse because the questions have changed. New customer segments, launches, seasons, policy updates, or market shifts can all move the query mix. So monitoring should look beyond accuracy scores. Track intent clusters, topic share, query complexity, conversation length, abandonment, and escalations. When new patterns appear, fold them into the evaluation set, so testing reflects today's users, not only launch day assumptions. Your application can change even when your code does not. A tool may rename a field, tighten authorization, alter timeout behavior, or change business logic. A model provider may silently upgrade a model, adjust safety filters, change tokenization, raise prices, or shift output style. Treat these dependencies as moving parts. Use contract tests to catch API changes, canary traffic to detect regressions early, fallback routing for outages, and model pinning when available. Track provider metrics separately as well, especially latency, errors, refusals, token usage, output length, cost, and quality scores. Regression detection asks a simple question. Did the new version make anything worse? For GenAI, that means comparing every meaningful change: prompts, models, retrieval indexes, tools, and orchestration. Start with a candidate version, run a golden test set, and compare both hard checks and judgment-based measures. Hard checks catch issues like invalid JSON or broken tool calls. Semantic checks look at helpfulness, correctness, grounding, latency, cost, and safety. Use benchmarks, pairwise tests, human review, calibrated LLM judges, and rules together. The key is to gate releases before deployment, so regressions trigger revision or rollback. Golden test sets are your regression safety net. They capture the cases that must keep working: routine workflows, high-risk decisions, edge cases, adversarial prompts, recent production failures, and business-critical intents. Each case needs more than an input. Define the expected behavior, pass criteria, required citations or tool calls, and outcomes that are never acceptable. Then compare new system outputs against those golden answers every release. Keep the suite versioned and reviewed as production changes. To avoid overfitting, separate development tests, release gates, and hidden evaluations. Quality monitoring is not just asking, was this answer good? It also asks, is the system behaving consistently? Run repeated tests across similar questions, user segments, and model versions. Then compare the answers semantically. Look for contradictions, unsupported claims, citation mismatches, hallucinations, refusals, format failures, and unexpected escalations. Clustering-related queries helps reveal when answers drift away from policy or source documents. When a metric worsens, use traces to connect the prompt, retrieved context, response, tool calls, latency, and evaluation score. That turns degradation into something diagnosable, not mysterious. Production feedback is only useful when it becomes an operational loop. Simple signals, such as ratings, comments, or did this solve it, help triage what went wrong. Low-risk patterns can feed annotation cues, creating labeled examples for evaluation, retrieval fixes, prompt changes, or fine-tuning. Higher-risk cases need expert review, especially when policy, compliance, safety, or domain judgment is involved. Serious incidents should escalate to the right owner: support, legal, security, engineering, or a specialist. The loop closes only when improvements are tested, released, and measured against real user outcomes. Continuous improvement works when every production signal becomes a managed change. An incident, user complaint, or metric drift should lead to diagnosis, then to a specific proposal. Update a prompt, tune retrieval, fix source documents, change the model, adjust guardrails, or redesign the workflow. Before deployment, evaluate that proposal against quality metrics, risk, business impact, compliance, and rollback readiness. Low-risk fixes can move quickly with lightweight approval. High-risk changes need formal review. The key is traceability. Signal, root cause, fix, evaluation, approval, release, and monitoring all stay connected. Reliable GenAI improves continuously, not accidentally. Drift can come from data, embeddings, prompts, tools, users, or providers. Regression management gives you golden tests, metrics, traces, version comparisons, and release gates. Human feedback turns production issues into learning loops. Next, we widen the lens to security, governance, privacy, and compliance for LLM applications.